So this is the 19th session of rigid body kinematics. This is in continuation of the 18th video. Okay. So in this also I'll take up numerical problems on pure rolling. Fine. So I'll take up several questions, and each question can be solved in different ways. I'll demonstrate all of them. Fine. So this is the question, part A. Now part A, what is part A? Part A of example. Okay. Now I'll write down the sentence. Okay. Consider the situation shown below in which all the details are given. Okay. The detail is this. This is a fixed vertical wall. This is a fixed horizontal surface. This is a plank. This is the drum. Center C, radius R, side view. This is right properly. Okay. Center C of the drum. This is radius. Here a string is attached here. Pulley is like this, like this. Here plank is moving rightward at a constant speed v with respect to ground. Okay, v with respect to ground. Okay, fine. Here this is a fixed pulley. This is an inextensible string. This is an inextensible string. Okay, this is an inextensible string. This is a fixed pulley. A string is attached to center C of the drum. It passes over this fixed pulley and is attached to the plank here. Okay, and here pure rolling takes place. And omega drum rotates at angular speed omega with respect to ground. Okay, the question is to find the value of the ratio V by R omega. To find V by R omega, that is the question. Okay, to find V by R omega is the required question. Now again, this can be solved by several ways. Okay, I'll solve it with two different methods. This is the plank. This is the material point P of the plank in contact with the drum, and D is the material point of drum in contact with the plank. Okay, fine. Omega is the angular velocity of drum with respect to ground. V is the speed of plank with respect to ground. The string is inextensible. String is attached to center C of the drum, passes over the fixed pulley, and is attached to this plank. Alright, fine. Now we have to find the value of the ratio V by R omega. So again, we can solve it by different methods. I'll solve it by method 1. We will apply SRC to the drum between the point C and D in ground frame. You can apply in plank frame also, there is no difficulty. Okay, as you solved the questions in previous video, with example A of previous video, 18th video. So SRC to drum in ground frame between the points C and D. Okay, so now selected point becomes C, other point becomes D. We draw the line joining SP and OP, that is C and D. We give the velocity of C to D, but we must know the velocity of C. Now see, the string is tight and inextensible, pulley is fixed. Therefore, if this plank moves rightward at a speed V, center of the drum should move at the same speed V towards left with respect to ground. The velocity of center C of drum with respect to ground is also V leftward. Velocity of center C of drum with respect to ground is V leftward. Alright, so we give a velocity of C is V leftward with respect to ground. So we give the velocity of selected point C to D. So give velocity of V to D in leftward direction. Now omega of drum with respect to ground is omega anti-clockwise. So we write down the sentence. D moves in anti-clockwise circle with C as center and R as radius. So for D to move in anti-clockwise circle with C as center and R radius, velocity of D should be R omega in rightward direction. The velocity of D is the vector sum of these two. Now they are not in the same direction, they are opposite directions. So V of D will either be R omega minus V or V minus R omega. If R omega exceeds V, then velocity of D will be R omega minus V in rightward direction. If V exceeds R omega, then velocity of D will be V minus R omega in leftward direction. But see here, pure rolling is taking place. So P is the material point of plant. It is moving at a velocity V towards rightward with respect to ground. Pure rolling is taking place. The velocity of D should also be V in rightward direction. Velocity of D should be in rightward direction with respect to ground. So resultant of these two should be in this direction. So this should exceed this. So velocity of D should be written as R omega minus V and not V minus R omega. So R omega minus V, that is the velocity of D with respect to ground. But velocity of D with respect to ground is same as velocity of P with respect to ground. That is V rightward. So this is just equal to V. So 2V is equal to R omega. So V by R omega is equal to 1 by 2 is therefore the required answer. Alright. So V by R omega becomes 1 by 2 and that is therefore the required answer. Alright. So V by R omega becomes 1 by 2. Alright. This I have, okay. So this is solved by method 1. Now we solve this by method 2. In method 2, we apply the concept omega is equal to relative normal speed by separation to the line CD of the drum. Alright, so this are a bit now. So method 2. Method 2, we apply the formula relative normal speed by separation to the points to the line CD. So we consider the line CD, C and D. Now we found that velocity of C is V leftward and velocity of D is same as velocity of point P of Planck with respect to ground, that is V rightward. Separation between C and D is R. Angular speed of this line is omega, same as the angular speed of drum with respect to ground. Now omega is equal to relative normal speed by separation. Both the normal speeds are in opposite direction. So relative speed will be sum of the speeds V and V, 2V by separation R. 2V by R is equal to omega. So 2V is equal to R omega. So V by R omega is equal to 1 by 2 is therefore the required answer. Alright. So by both the methods we obtain the same answer. Alright. Now this I'll rub it, alright. Now solve another part B of the another question. Next question I discuss. Okay. Again I draw the diagram in which all the details are given. This is a side view. This is the fixed ceiling. This is nothing but the fixed ceiling. This is the string hanging from the ceiling. Here we have a cylinder whose center is at C1 and radius is R. A string is folded, inextensible string is folded on the cylinder several times and this string comes here. This is attached to another cylinder whose center is at C2 and whose radius is same R. Now center C2 of cylinder moves at a constant at speed V downward with respect to ground. Also we are given that the angular speed of this upper cylinder is omega with respect to ground in anti-clockwise sense. And we are also given that angular speed of this lower cylinder is omega with respect to ground in clockwise sense. And this is the inextensible string. This is the inextensible string. Okay. And here string and cylinder, there is no slip here, no slip. No slip between string and cylinder. between string and cylinder. No slip between string and cylinder we simply write in short as ns. Here also there is ns, no slip. Okay, fine. Or here see center C1 is fixed. Center C1 of upper cylinder is fixed. And center C2 of lower cylinder is moving at a speed v with respect to ground. And both these angular velocities are with respect to ground. To find the ratio v by r omega unknown, this we have to find. We find the value of the ratio v by r omega. Okay. This also can be solved with different methods. Okay. I'll again solve it by two different methods. Method 1, method 2. As I did in part A of this video. Okay. Previous question of this video. So method 1. So what we do, we have to apply, first we start from here. See, here there is no slip, here also there is no slip. So we have to apply no slip at both these 2 points. We have to apply no slip at both these 2 points. Alright. So we apply no slip condition here. So this is center C1, this is fixed. This is the point D1 of the upper drum which is contacted with the string here. Now this C1 is fixed in ground. This is rotating at angular speed omega, anticlockwise. So this D1 moves in a circle whose center is at C1 radius r and angular speed is omega. Velocity of D is nothing but omega r from theory of circular motion of point. Here there is no slip between the drum and the string. The velocity of this string is also how much? Omega r in downward direction. The velocity of this point of the string is omega r in downward direction. Now this string is inextensible string. So this string continues here and is wound over the lower cylinder. Velocity of this point of string will also be, velocity of this point of the string in contact with lower cylinder will also be omega r in downward direction. Now here there is no slip. So velocity of this point of the cylinder with respect to ground will also be omega r in downward direction. No slip condition, this is what it implies, no slip. Since these 2 points are not slipping, so in tangent plane these 2 points should have the same velocity. So this point of string has omega r in downward direction. So this point of string pulley should also have a speed of omega r in downward direction with respect to ground. Now this point C2 is the center of the lower pulley, is moving at a speed v. And this is having an angular speed of omega. Okay. Now let us call this point as D2. Fine. Now what we do, we apply SRC for velocity to the lower cylinder between the points C2 and D2 in ground frame. Alright. Now this I'll rub it. So now what we do, we apply SRC to drum lower cylinder, sometimes call it as cylinder, sometimes call it as drum, whatever it is, lower cylinder between C2 and D2, between C2 and D2 in ground frame. So SP arrow C2, OP arrow D2. Then you draw the line joining C2 and D2, whose orientation is same as in the problem, it is horizontal. So I draw the horizontal line C2 D2. Now we give the speed of C2 to D2. Velocity of C2 is V downward, so this I give as V downward. Now I write down the sentence. D2 moves in a clockwise circle with C2 as center and radius r. So if D2 is to move in a clockwise circle with center at C2 and radius r, it should be given a speed of omega r in upward direction. So velocity of D2 is the vector sum of these two. But velocity of the point of the string in contact with D2 is omega r in downward direction. And here it is no slip. So velocity of point D2 of drum should also be omega r in downward direction. So resultant of these two should be omega r in downward direction. So this should be more than this. So V minus omega r should be the velocity of D2. That is same as equal to omega r. V is also equal to 2 omega r. V by r omega is equal to 2. Is therefore the required answer. Alright. So V by omega r becomes how much? V by omega r just becomes equal to 2, which is therefore the required answer. Alright. So this was the method 1. Now what I do, I solve this question by method 2. Okay. Solve this question by method 2. Or method 2 also solve this question. Now method 2. Method 2, we apply the formula omega is equal to relative normal speed by separation to the lower cylinder in ground frame. Now omega of lower cylinder with respect to ground is omega clockwise. That is equal to relative normal separation by speed by separation. So I draw the line joining C2 and D2. I draw the line joining C2 and D2. This is C2, this is D2. This is R. Velocity of C2 is given to be V downward. And velocity of D2, as explained previously, is also omega R in downward direction. From no slip condition here. Now, this angular speed of this line C2 D2 is same as angular speed of lower cylinder with respect to ground, omega clockwise. So angular speed of this line is C2 D2 is also omega clockwise. So omega should be relative normal speed by separation. Now since omega is clockwise, so this should exceed this much. They are in same direction. So relative speed should be V minus omega R by R. So V minus omega R should be R omega. V should be 2R omega. V by R omega should be 2. That is therefore the required answer. Alright. So by both the methods we obtain the same answer. So this was another method of solving this question. Fine. Now I'll drop this one. Now I'll take up another question, part C. If you go through all these problems, if you understand properly, and you take up any other question from any other source, I am sure you will be able to solve most of them. There is no doubt about it. So you carefully go through the examples, okay? And if you understand it, you try problems from some other source, you will be able to solve it. And you tell your friends also to look at these videos, okay? Now I'll take up the problem part C of this question. Now part C, I'll draw the diagram again, okay? All the details are given in the diagram. This is a fixed ceiling, okay? This is an inextensible string. Upper end of the string is attached to the fixed ceiling. Inextensible string it is. It is attached to an inner cylinder, okay? This is a double cylinder whose side view is given. And here a block of mass M is here. Some block is mass not given. Some block is attached to the string. This is the center C of C, and this inner radius is R. Outer radius is 5R. This is a double cylinder. These two together they are a double cylinder. They are a double cylinder. It's a double cylinder whose C is the center, R is the radius of inner cylinder, and 5R is the radius of outer cylinder. So these two cylinders are rigidly joined to each other. So it's a combined thing, is a rigid body. So this is an inextensible string. This is an inextensible string. It is an inextensible what? String. This is also an inextensible string. Alright. And here it is no slip. No slip between the string and the inner cylinder, which in short we write as NS. Here also the string and between the string and the outer cylinder there is no slip, NS. Okay. And center C is moving downward at a constant speed V, at a speed V. And velocity of this block is V1. Now question is, we have to find V1 by V unknown. We have to find the value of the ratio of V1 by V. We have to determine the value of the ratio of V1 by V. Okay. V1 is the speed of this block. It is moving downward at a speed V1 at this instant. So this and this are inextensible string. Here there is no slip. Here also it is no slip. So as the center goes down, the string unwinds. String unfolds over the inner cylinder. It becomes longer and longer. And this block also moves downward. Okay. And here they both have no slip. And string is inextensible. We have to find the value of the ratio of V1 by V. Now one more thing to be noted down in this diagram. As the center moves down, the double cylinder will rotate at some angular speed omega with respect to ground. Okay. So this are a bit now. So again this can be solved by several ways. Okay. So we can, I use that formula. SRC also you can solve by relative normal speed by separation, also you can solve, whichever you want, okay. I'll solve it that concept, relative normal speed by separation. I use that concept. So what we do first, you consider, let this point be a point of the inner cylinder in contact with the string is P1 say at this instant, and P2 is the point of the outer cylinder in contact with the string at this instant, alright, and P1 is the point of the inner cylinder in contact with the string P1. P2 is the point of outer cylinder in contact with the string at this instant. And it is seen from diagram that P1, C and P2 are collinear. Okay, fine. So now we have to find the ratio V1 by V. See, the block is moving at a speed V1. Okay, this string is inextensible. All points of the string are moving at a speed V1. So this point of string is also moving downward at a speed V1. Here it is no slip. So this point P2 of the outer cylinder will also have a speed V1 in downward direction. Alright. So we consider the lines C and P2. C, P2. This is C, this is P2. This distance is C to P2 is how much? 5r. Now C is moving at a speed V downward and P2 is moving at a speed V1 downward. This is angular speed omega of the double cylinder, okay. So this double cylinder is actually a single rigid body in which two cylinders are there which are rigidly fixed to each other, okay. Now relative speed of this line CP2, angular speed of this line CP2 is omega in clockwise. That is equal to relative normal speed by separation. Since omega is clockwise, so this should exceed this. So omega should be written as V1 minus V by 5r. Okay. So V1 minus V by 5r is equal to omega. Alright. Now you consider this point here. This point, this is the most vital point of the problem. See, this is the inner cylinder. Okay. See, like this. Like this, see. This is center C. As the center C moves down, the string unfolds. Length of the straight segment of the string goes on increasing. As the center C moves downward, the drum rotates clockwise, the string unfolds. The length of this string, which is vertical segment of the string, goes on increasing. Length of the vertical segment of the string goes on increasing. So at any instant of time, this is the length of the vertical segment of the string. One more point to note it down. This is the fixed ceiling here. This point is also at rest. String is inextensible. So this point of string, which is just the lowest point of the vertical segment of the string, that is also at rest with respect to ground. So this point of lowest point of the vertical segment of the string at any instant is also at rest. But here also we know that there is no slip here. So the speed of the point of the inner cylinder just in contact with the lowest point of the vertical segment of the string, that is also 0. Okay, fine. So now you see this. This is C here, P2 here, P1 is here. As I explained just now, P1 is also at rest. P1 is also at what? Rest. As I explained just now, P1 is also at rest. So see, this distance is how much? R. Now angular speed of this line CP1 is also what? Omega. Same, because P1, CP2 they are fixed in this drum. So angular speed of CP1 is same as angular speed of CP2. So angular speed of CP1 is relative normal speed by separation. That is V minus 0 by R. V minus 0 by R, that is omega. So V is equal to R omega. So now you substitute this formula here. R omega is V. From this equation we see V1 minus V is equal to 5R omega. But R omega is how much? V. So this is replaced by V. V1 minus V is equal to 5V. V1 is equal to 6V. So V1 by V is just equal to 6. This is therefore the required answer. Okay. So this was solved by the method of relative normal speed by separation. Alright. So this is the answer which you get. So answer is V1 by V equal to 6. Alright. This was the 19th session on rigid body kinematics. Okay. So I'll take one or two sessions more. I'll take on rigid body kinematics on the second chapter of this rigid body kinematics. Then I'll pass on to third chapter and then fourth chapter, and then rigid body kinematics chapter will be finished. Fine. So I advise that you go through this problem You understand it properly. You try problem for any other source, any other book, any other test sheet, whichever you think suitable, and then I think you will be able to solve most of them. And tell your friends also to go through these videos. Okay, it will be very helpful for them. Okay, so I close it here.